So this activity is called a game of clones, and it is a role play activity, a classroom-based role play activity, and it is modelling the development of antibiotic resistance and how natural selection is an explanation for how antibiotic resistance amongst bacteria arises. So students act as bacterial cells. An area in the classroom is cleared, and 10 students are asked to stand in the centre of the classroom. So that area would be, say, the body of a patient, in which there are 10. Those bacterial cells are the disease-causing bacteria. Teacher acts as the doctor who's treating the patient. Each of the students is given 5 cards, and if a bacterial cell gets 3 or more red cards, then it's going to be resistant to the level of antibiotic that the patient is being treated with. So each of the students gets 5 cards, and the doctor, the teacher, treats the patient with the antibiotic, with a dose of antibiotic. And if a bacterial cell, if a student has 3 or more red cards, then they survive, and if they don't, then they die. So the surviving students then have a chance to reproduce, and during that reproduction event, each of the bacterial cells will produce a clone. But a mutation event can occur during that reproduction event. So in order to see how that affects that bacterial, that cell and its offspring, its clone, a dice is rolled, a single die is rolled. So when a die is rolled, and if a student gets 1 or 2, then it will mean that it swaps out a black card for a red card. If it gets a 5 or a 6, then it'll get an extra red card swapping out for one of its black cards. And if it gets a 3 or 4, then there's no change. So that adds another level of chance, random mutations occurring in the population. And again, the teacher will treat the patient with the infection, with the dose of antibiotic. And over time, then the population changes quite quickly over a number of generations. It'll be seen then by the students that at the dose of antibiotic that's being used, then the antibiotic resistance is building up within the population, and in fact, antibiotic resistant bacteria are being selected for by the presence of the antibiotic.